this. Any solutions? Anyone?
I got halfway through it, but I got halfway through it 3 times and then realised I was wrong. So this is the only time I'm doing it right, and it's stressing me out.
It shouldn't stress you out. Being wrong is a normal state of affairs. I'm wrong all the time. Well, maybe not in these things anymore, but because I've done them. Usual stuff. Yeah, I make a lot of mistakes, so we'll see. Anyway, creating the dual, does it show? No. So, oh, giving away to no. Okay, I'll make it a bit smaller. Yeah. Is this still readable? Well, there's no surprise there, is there? Maximize in this LP turns into minimize in this LP. 5 and 20 in the objective turn into 5 and 20 in the right-hand side. These two right-hand sides. Thank you. These two right-hand sides turn into the objective coefficients. And 3 and 1, 3 and 1, 2 and 3, 2 and 3. Okay, that's dualization. Did you get that, Libby? This bit?
Yeah.
Okay, good. So then, when you continue, you do a first tableau, and that's probably a bit more tedious. And so the way we did pivoting problems that are greater than or equal to in the constraints, the way we did it last year was introduce artificial variables, G objective. Does that ring a bell? Hopefully. And then pivot on the G objective, so you would go for the 5 and try to get off the A's from the basis, find a feasible solution, optimize everything, and final tableau after all this that you would get, it would be this one. And oh, okay. Now, if you compare this tableau to when we were solving the original LP in the previous homework, so what we found in the previous homework was that the objective would be 1400, and it's still 1400, which is good because that's what I promised you. But you can also, what have I done? Should be a 20 and a 70. I don't know why I put the minuses there. But you can also see that this 20 and this 70 looks conspicuously similar to this 20 and this 70. And this 20 thirds and this 5 thirds looks suspiciously similar to these numbers. And again, that's not a coincidence. That's a certain property of the primal and dual simplex tableaus, but we'll get there in due time. Okay, so I'm not showing all the steps between here, I'm just giving you the answer, because there's not enough, well, there's no point in doing it. Now, when we look at question number 3, here you were just asked to write a bit larger, the dual of that. And what is not standard about this problem is that these are not less than or equal to, but they're equal. And so what we said was, when there are equalities in the constraints rather than inequalities as you're expecting, then you don't put any constraint on the non-negativity of y1, y2. So y1 and y2 will be allowed to be any numbers. Don't have to be non-negative. Y3 still has to be non-negative. The reason is because as we were deriving the dual, remember y1 was something that multiplies the whole constraint, y2 is something that multiplies the second constraint, and y3 is a coefficient that multiplies the third constraint, and you don't want to flip the sign here. That's why you need y3 to be non-negative. But here, it doesn't matter whether y1, y2 is negative or not. Okay? So, the answer would be this. And everything is just as you would expect, except these two non-negativity constraints that you would normally want there, they're missing. Okay? So those people who have attempted this, any questions? No? Okay. Let's move on then. So as usual, you can put the number of marks that you got for the homework, 1, 2, or 3, or not, on the register. And thank you. Right, the topic that we'll be talking about today, and being clear.
In the first tableau on the G line, is there any A values?
Yeah, we can one together.
In the homework again.
Yeah.
Oh, no.
Did I get it wrong?
Okay.
Okay, I'll switch back.
I thought Giro was just together.
This tableau.
Yeah.
Say that question
Should
again.
there be any artificial values in the G row?
Here.
Yeah.
No.
Oh shit.
Put it on again, I don't get it. I'm not doing it again.
Yes, right.
I'm not. Give up.
That should
Okay, thank you.
So, well, they're in the basis. So, because they're in the basis, their column has to look 1 in their row and 0s everywhere else, which includes the G row. So, therefore, no. Right. Example problem for dual pivoting. Now, if I asked you last year to solve this problem, what would you do? Anyone?
Oh, don't some of them have slacks and some of them have artificials?
Yes. So you'd add the artificials in the first two constraints?
Yeah, because of that means
Okay.
it's artificial.
Yes, that's quite right. And the third one doesn't need any artificial. Okay. So now I'll show you a nicer way of dealing with this thing, which is called dual pivoting, which is deemed too hard for the first year. or maybe you just don't want to tell the students who are not picking OR in the second year. This nice method. Okay, so this method works by, if you remember, last year we always wanted all the values in the val to be non-negative. Every time you entered something negative into the val column, I told you no, 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 definitely not. And that restriction is now being lifted. So the dual pivoting way of dealing with a problem like this, which is to minimize this objective, subject to some constraints that might be greater than or equal to, is to first multiply the equations which are greater than or equal to by -1, and multiplying them by -1, the sign switches to less than or equal to. So we get these three constraints. Okay. And now we have a more or less standard problem, because everything is less than or equal to. However, there's still, we don't really know how to find a feasible solution because we have these negative numbers in the right-hand side. So if we plug zeros everywhere, as we used to do, we won't get a feasible solution. Okay? So we have to do something else. What we have to do is following trick. So we write the tableau like usual. Everything was less than or equal to, so we have slack variables everywhere, no artificial variables. And the problem we have are these right-hand sides here. So what we do when we have right-hand sides here is we pivot in a slightly different way. And pivoting in a slightly different way means not that we do the actual row reductions in a different way, but we select the pivot element in a different way. Okay? And the way we select the pivot element here is we look at the numbers in the val column, and some of them are negative. And if they're negative, we want to get rid of them, because we want a feasible solution, and the feasible solution has to have non-negative values in the val column. Okay? So we select one of the negative ones. Perhaps the -6 is the natural choice because it's more negative than the other one. Well, there is such a thing as more negative. And we want to pivot in the S2 row. Okay? So what we do is look at this -6, and we want to pivot in this row. Because it's negative. Now, how do we select the pivot element in that row? Can anybody guess? Ratio. That is a decent guess. So, what ratios would we do?
The numbers of rows in the row divided by the objective row.
The val divided by
No, the other way around.
the obj divided by this, or this divided by that, or this divided by that,
Now I'm confused.
or everything divided by 0. Okay, who have I not managed to confuse? One person still alive. Excellent. We actually, now the first thing we look at is, because we want to get rid of this -6, and we want something positive there. So the first consideration is we want a negative pivot element, because the first row reduction that we're doing, or the first row operation that we're doing, is dividing this whole row by the pivot element. And if we select a negative pivot element, then this -6 is going to go away and become positive. Right? So what we're looking at is either this -3 or this -1. And now come the ratios. And the ratios we do in this case, so we're looking at these possible choices for a pivot element. And the ratios are quote, because it's not really mathematical notation, of divided by the pivot row entry. Okay, and so here what do we get? 2/3, because it's the -2 in the arch divided by the -3 in the S2 row. So there it's 2/3, and here it's 1. And just like before, we do the least ratio. And the least ratio is this one. So the -3 is going to be after the summation. Okay. Is it clear how I've selected the pivot element? So I say that again. No reaction. That's the worst thing that can ever happen. Ask a question. Well, no one wants to know, and I'll just continue. So now we found the pivot element, and the pivot step afterwards is just like always. Which means that bases get changed. Okay, so S2 and X2 are swapped in the bases. So second row is now going to be X2. The other variables remain in the bases. The X2 row is divided by the pivot element, so divided by -3, which means we get values, well, like 2 on the so quickly. -1. -1. 1. -1/3. -1/3.
Wouldn't that be positive?
Yeah, is it?
I don't know.
-1 over -3.
Oh, yeah. That's it.
It would be 0.
And then that one's minus.
This one's -1/3.
Yeah.
And this one's 0. Okay. So this is just like before. I've just divided by the pivot element. And the rest of the tableau, main point we want is we want 0 here, 0 there, 0 there. We're doing row reductions. So we're taking the original rows and adding a suitable multiple of the pivot row to them, so we get the zeros. Okay. So the first row will be the original first row plus this row. That's giving me a 0 there, I think. Or the other numbers. So this is a -1, is that right? -3 plus 2. -3 plus -1 is -4. What's next? That's the one that I want to be 0.
Yeah.
0. No, because you're doing the new second row, so that's -2/3, is it? And then this has to be 1. This has to be -1/3. And the last one should be 0.
Would that not be a positive third?
Would that not be a positive?
The 0 take away a negative third.
Yeah, double negatives.
Where? I'm not doing double negatives, I'm doing this.
Which
plus
row are we
this.
on?
Plus that.
Yeah. So that I get -1 plus 1 is 0.
Right, no, that works.
Okay?
I've just done acceleration.
But that doesn't really matter, so I'm not going to spend much more time on that. What I'm going to do is copy it off my notes. 1, 2, 0, 2/3, 0, 1/3, and this should be 4 minus 5, 0 minus 1/3, 0 minus 2/3, 0, and now that you're finished copying, I can tell you a trick that on your handout and turn over, you've got this tableau. Okay, so the pivot step is just a revision, so there's nothing really special about it. Let's look at the new tableau that we have here. What do you people reckon? Is that good or bad?
So let's get rid of -1.
Yeah, it's better than before. There's only one negative element. Well, it's still not quite good because there's a negative element in the valve. Okay, so now the obvious thing to do is just to continue the way we've started. So this -1 is going to tell me which element, which row I want to pivot in. Now tell me what's going to be the pivot element in this row. I can't remember. How did you come up with X1? Okay, so we know the row. How do we get the column?
It should be x3 because it's the smallest ratio.
Is it the smallest ratio? Is it okay? So let's do the ratios. Ratio is the right word here. So the ratios. And again, we're only looking at the negative entries, and the negative entries we've got here 5/4. Here we've got 1/2. And this one's 2. So Libby's right. So these are the ratios, this is 1/2, and therefore this is my pivot element. Okay, so for revision, select the pivot row by looking for something negative. Do the ratios last row divided by the potential pivot element, but only do them where the pivot element is negative. So here it's 0, I can't do 0 divided by 0, it doesn't exist. And here it's 1, so I don't even do the 0 divided by 1. Okay. Otherwise, if I got one of the ratios to be 0, I would have to take that 0. But I wouldn't really have to, but it would be advisable. So for your purposes, you would have to. And we get with this 1/2. Now, again, remember this. When we talk about dual pivoting, what is different is how we select the pivot element. Right? What is not different at all is how we actually recalculate the new tableau. That is exactly the same. Once you know which entry in the table is your pivot element, then what you do is exactly the same as what you're used to doing from last year. So now I don't think you have a copy of this in the new tableau, but the basis is going to be S1, X2. No, it's not. What's the basis going to be? I don't have a copy of this.
X3, X2, S3.
Thank you. I see you get the idea. What? X3, X2, S3. Okay, and the X3 row should be 3 over 2, 6, 0, 1, minus 3 over 2. If you find something fishy, tell me. I can't guarantee that everything is correct in what I do. 3 over 2, minus 3, 1, 0, minus 1 half, 0, and the S3 row is, did you get 0 there? Yeah, seems alright. Minus 2, 0, 0, 1, 0, 1, and the objective is 4.5 or 9 over 2, minus 3, 0, very much, 1 half, minus 1 half. Okay. So that's not, hopefully that's correct. So what I've done is divide this by minus 2/3. It's like multiplying by minus 3 over 2. So this is correct at least. And the other rows. This one I can check easily because it's the sum of these two.
Yeah.
Minus 2, 0, 0, 1, 0. Yeah, okay. Random check. Things I check work. Okay, so what do we do now? Good or bad? Another problem then? No?
Now do we go and try and get rid of the negatives in the objective value?
Right.
The objective row.
Why would we do that?
Taking the maximum.
Yes. So we would do that if we wanted to maximize, but we don't want to maximize, we were told to minimize, and because minimization is finished when there's nothing positive other than the val in the objective row, that looks okay, this looks okay, so we can conclude that that's the optimal solution, or a optimal solution. Yeah. So optimal. What we get in this case is x2 and x3 are both 3 over 2. x1 is not in the basis, so it's 0. And all the slug variables are also 0. And the objective is 2. So that's how you do dual pivoting. Any questions? Good. Okay. So the next slide, as you can see, in the handout, asks, why is this called dual pivoting? And this is called dual pivoting because, so what you can see here is that it's the original problem again, because the dual is, okay, what is the dual of this problem? Is to maximize. Right, so before I do the dual, in fact, I want to make my life easy. So I look, so this third constraint is kind of nasty because it has less than or equal to, and when we're doing dualization for the minimization problems, we prefer greater than or equal to. So what I'm going to do is just multiply the whole constraint by -1, so I get an equivalent one which says that minus x1 minus x2 minus x3. Am I running out of screen space? Is greater than or equal to -3. Okay, that's just this constraint times by -1. And so with the new formulation, slightly better. What is the what's the dual?
Maximize three,
Maximize 3, 6.
and 3, the ones in the.
Yes, that is going in the right direction. But so we typically use y's for the decision variables, and we're taking the 3, 6, and -3 as efficient. So 3y1 plus 6y2 minus 3y3. Yeah, coming from 3, 6, and -3. And now what are the constraints?
3y1
3y1
plus 3y2.
minus, in fact, minus 3y2,
Oh, never mind.
because I'm going at, well, not that, but the new one. Yeah. So minus y3
Plus y3.
should be less than or equal to, because I'm going from minimization greater to maximization less. And it should be 3. And that 3 is coming from here. Okay. And then let's see the rest. Should be y1 plus 3, y2 minus y3 less than or equal to 2. Right? So with me. And the last comes from x3 coefficients, which are 1, 1, minus 1. So we'll have y1 plus y2 minus y3 less than or equal to, what's the coefficient at x3? 1. Okay. And I want all the y's to be non-negative. y1, y2, y3. Okay, any questions? Easy enough? Why not? Just keep in mind always that a constraint here corresponds to a variable there, and vice versa. A constraint here corresponds to a variable there, so you can't go wrong with the numbers then. Okay. That's the dual. And now this is just a normal maximization problem. Yeah, of the sort that we've done loads of before. So how would you do this maximization problem? Well, the tableau is here. It's also in your handout, so you don't have to copy everything. And this is just a box standard maximization problem. So what do you do?
Oh, okay.
Most
Most
negative.
Something negative, yeah, the most negative in the objective row?
Yeah.
Excellent. So that's the most negative. Now, what do you do next? Ratios? Well, you don't want the -3, right? Because you only want the positive pivot element. So the ratios would be 2/3 and 1. So Based on the ratios, you pick S2, and which means that the new basis is going to be S1, what am I putting there? Y2, S3, and I don't want to bore you with the rest. So what I'm only going to do is the val and the objective, because they're important values. So the val column should be, unless I've messed it up, 5, 2/3, 1/3, and the objective is 4. And then the rest of the objective, I have -1, 0, 1, 0, 2, 0. You can fill in the rest, but it's not really so important. Okay, that's what I got when I did the pivot on the 3. I'll mark the 3. That's the pivot element. Okay, so now when you turn back to the first dual tableau, which I've got here, what do we get? There was 4 in the objective, there's 4 in the objective here, then there was -1, 2, and 1. It's still -1, 2, and 1 there. 2 was with x2. Okay, now x2 is s2. -1 was s1. Okay, so now that's y1. So s1 is the slack variable of the first constraint. Y1 is the dual variable of the first constraint. So Y1 and S1 are somehow paired here. Right? So Y1, I can see the S1 that I had in the previous tableau. Are you following that? You see? There you go. Good. Okay. And then what I have in the val, when I look at the under the heading example step 2, so the first one we got in the dual pivoting process, I had a -5. No, what did I have? -5. 9 over 5, -1/3. That's suspicious. Oh yeah, it's not as suspicious as it looks. Anyway, you get the idea. Okay, so these numbers are the same. So this is a big observation. So so what we see here is that kind of normal pivoting of the dual LP is somehow wiggly equal to the dual pivoting in the primal or the original LP. And somehow, when you have two tableaus, like we have this one and the one that we got after the first pivot, the first time round, which has similar values, or the one that we started with in the original problem, which was under the example. So that had -3, -6, and 3. There's something wrong somewhere. I don't know what's wrong. What have I done wrong? There's some negatives and positives are the wrong way round, aren't they? somewhere. Anyway, I need to find my error. I'm not going to do it now because that would take too much time. But point is, when you look at it, you get 3, 2, 1. You get, oh no, maybe they should be the wrong sign. I don't know. I'll have to think about it. But you've got the 3, 2, 1, and the -3, -2, -1 in the objective row there, and you've got the -3, -6, 3, and you've got the -3, -6, 3 in the val or when we were doing the dual pivoting. So these tableaus, they just correspond. They come one with the other, and at the same time, the dual solution. Here you've got a dual feasible solution, which is y2 is 2/3, and y1 and y3 are 0. And that corresponds to a dual non-feasible solution, which is x2 is 2, and x1 and x3 are 0. So also the tableaus are somehow in a correspondence, and the solutions are in a correspondence. And so what we're looking for, when I go back here, this is the final tableau for our problem. Now, it happens that the optimal solution is this, but you can also read off the optimal solution of the dual, which will be, well, the objective of the dual will always be the same, and 1/2 and 1/2, or y1 equal 1/2 and y2 equal 1/2 will be the optimal solution of the dual. This is what you see in Tableau. So the big advantage is you don't have to solve both the primal and the dual. When you solve one and you've got the final Tableau, you can see the optimal solution to both LPs in the same Tableau. Does that make sense? I've gone a bit off script now, so maybe it's a bit confused, but that's the main message. So the message is the primal and dual, they just come in a pair, and when you solve one, you've already solved the other as well. Okay, so here we would need another pivot because there's still something negative there. So we would do after another pivot step. We get the optimal y1 and y2 were 1/2, and y3 is 0. The primal Tableau. Yeah, I hope it makes sense in spite of me getting a bit confused. Any questions? All good. So the final slide and the final bit of your handout is a summary of how the dual pivoting process works. The dual pivoting process works. Finding a pivot row, we go for a negative number in the val. As a rule of thumb, you take the most negative one, which corresponds to choosing the most negative entry in the objective row in the normal pivoting. Then you have to do a ratio test, sometimes, which is not strictly dual pivoting. So sometimes you have the wrong sign in the objective row. So it never happened to us. We were trying to minimize, and everything was already negative or 0 in the objective row, so we didn't have to do any final pivoting. But sometimes you have the wrong sign. It's not strictly the dual method, it's some kind of a primal dual combined pivoting, but that works as well. So you can play around with these tableaus in any way you want. The pivot step is normal. Keep going until everything is as it should be. Okay, and being as it should be is that the val is all non-negative and the obj is all the right signs that you want, depending on whether you're minimizing or maximizing. End of explanation. There's some homework again. And that, I guess, is everything from me for now.